ladies and gentlemen, welcome back to a little bit of geometry. This is part 2 for 11.6, and we're looking at some examples for surface area of pyramids and cones. Okay, so example 1. Here we have a pyramid. Okay, to find the lateral area and surface area, let's start with the lateral area. Alright, so the lateral area, if you remember, is 1/2 perimeter times the slant height. Now this looks like the formula for a triangle. That's because it is. You're finding the area of one of these triangles and then multiplying it by how many sides there are. That's basically where this perimeter comes in, because you have to do it times 6. So you could just find the area of one triangle and then do it times 6, or you could do the times 6 here and find the perimeter. And so we do 1/2, and one of these sides is 10, so we can do 10 times 6. That gives us a perimeter of 60. Alright, and then times the slant height, that's 14, and that gives us a total of 420. Alright, now we want to find the surface area. To the surface area, we have to also add the base. Now, in the previous lesson, you learned how to find the area of a polygon. So the surface area is going to be the base plus the lateral area. All right. So the base here is we find one of these triangles basically, and then multiply it by the perimeter. So we want to find 1/2 the apothem times the perimeter. Okay, 1/2 the apothem, half of 5 radical 3, and then times the perimeter, which is 60, and then we have to add the 420 that we found up here to it, plus 420. This comes out to be about, well, more exactly 150 radical 3 plus the 420. And here's our approximation, because radical 3 is going to give us a decimal, so that is about 679.81. All right. So we've got our lateral area, 420, and our surface area, we have to add the base to that. All right, finding the lateral and surface area of a cone. Okay, for the cone, we want to first find the slant height here. And notice we have a right triangle, so we're going to use the Pythagorean theorem to find the slant height. So the slant height here is a squared plus b squared, and then we have to find the square root of that. So square root of a squared plus b squared, that's 8 squared plus 6 squared, and that is 10. All right, notice this is a Pythagorean triple. The 3, 4, 5 just doubled. 6, 8, 10. All right, so this is 10. Then we find the lateral area by doing pi times the radius times slant height, pi RL. So that is pi times, we have the radius, that's 6. And then the slant height, that's 10. So that's 60 pi. Or if we want to convert that to decimal, approximately 188.5. Now the surface area is going to be, again, the base plus the lateral area. Okay, so that's, we could say pi r squared plus pi rl. All right, and that's going to give me pi times 6 squared plus 60 pi, and that gives us 96 pi, or we can say approximately 301.59. All right, next, solving a real-life problem. Okay, it says the traffic cone can be approximated by a right cone with a radius of 5.7 inches and a height of 18 inches. I'm going to go through this one quickly because it's like the previous one, so I'll just post what it is. All right, and then we know the slant height, same deal again, Pythagorean theorem, we get about 18.88. And now the lateral area, we're going to use that 18.88, multiply that by pi times the radius 5.7 times 18.88, and that gets us approximately 338.1 or 0.10. All right, now we're looking for the surface area of a composite solid. Now notice that one is on top of the other. That means this base right here is not included in the surface area, right? Just the one on the bottom here. Okay, so if we want to find the lateral area, we have to find the lateral area. So the lateral area is going to be the lateral area of the cone plus the lateral area of the cylinder. Okay, and so that's going to give us pi r times the slant height plus 2 pi rh. And here we have 3 and 5. 3 and 5. So pi times 3 times 5 plus 2 pi times 3 times 6. All right, and that comes out to be 51 pi, or approximately 160.22. Then if we want to know the whole surface area, we have to add the area of the base to that. All right, so that's going to be the surface area is the lateral area plus the base. We have the lateral area here, that's 160, and the base is pi r squared, so it's going to be the 160.22 plus pi times radius squared, and that comes out to be approximately 188.5. All right, if we want to change the measures of a solid by a factor, here they're saying multiply the radius by this factor. All right, so if I want to multiply the radius, I do 10 times 3 over 2, and that's 15. So I want to compare these. The original surface area was pi times 10 squared plus pi times 10 times 26. Okay, and that gives me 360 pi meters squared. All right, the new surface area with using 15 would be pi times 15 squared plus pi times 15 times 26. And that would give me a surface area of 615 pi meters squared. If I want to see what the how it affects the surface area from the original one, then I could put the new over the original, new to original, 615 pi over 360 pi. Pi cancels out, so I'm left with 615 over 360. That simplifies down to 41 over 24. So it's 41 over 24 times the original surface area. Now if I want to multiply all of the measures by it, then we already have the original. So now I'm going to do the new surface area is pi times 15 squared plus pi times 15 times, this time 39, and that gives me an area of 810 pi meters squared. Now compare that. If I take 810 pi over the 360 pi, pi cancels out again, and then I can simplify down to 9/4. Now if you look at 9/4 and compare that to this factor, 9 is 3 squared, 4 is 2 squared. I could rewrite this as 3 over 2 squared. So when I change all the dimensions of a solid by the same factor, if I change them all by the same factor, then I could just take the surface area times that factor squared. Okay, so area, remember, squared. So if I just take one side, multiply it by this. If I want to do the area, I do all of the sides, and that gives me the surface area times that factor squared. Okay, let's look and see how we can use this. If I want to find the surface area of a similar pyramid, okay, I have this surface area. I want to find the factor, so I put the new over original to find the factor. Okay, so the scale factor would be 7.5 over 6, new to original. Okay, now if I want to find the new surface area, we could simplify this down. That would also equal 5 over 4. If I want to simplify that down to non-decimals. And then I can take the surface area and multiply it by this factor squared. So I take 156 times 5 over 4 squared. Okay, and that gives me a new surface area of 243.75, and that is in square meters, meters squared. All right, and let's see, we've got one more example. If I want to find the surface area of a similar cone, all right, again, we want to take new to original. So this is the one we're finding, that's the new. So I'm going to put 2.5 over 5, simplify that down. That is a factor of 1/2. So I'm going to take this surface area, 85 pi, times 1/2 squared. A half squared is 1/4, so 85 times 1/4 is 21.25, and that's going to be pi, and that is in square inches, inches squared. And there you have it, ladies and gentlemen. That's about all the fun we can have today. Okay, check in again next time. Good times in the Matherhood.